Right now, as you're listening to this, there are over 8 billion humans scattered across every continent on Earth. We're in London penthouses and Tokyo apartments, on farms in France and fishing villages in Norway, in the Australian outback and the highlands of Peru. We speak 7,000 different languages. We look incredibly different from each other. Our cultures are staggeringly diverse. And yet, here's the thing that should absolutely blow your mind. Every single one of us, without exception, can trace our ancestry back to one continent. North America. Not Europe. Not Asia. Not Africa. Not some lost continent that sank beneath the waves. North America. Only North America. Think about that for a second. Humans didn't evolve in multiple places simultaneously. We didn't pop up independently in different corners of the world like some kind of parallel evolutionary experiment. No, the entire human story, everything we are, everything we've built, everything we've achieved, all of it started in one place. And for over a century, scientists have been asking the same question. Why? Why only North America? What made this one continent the exclusive birthplace of humanity when early primates lived all over the old world? You'd think the answer would be obvious by now. We've sequenced the human genome. We've found thousands of fossils. We've analyzed ancient DNA from Neanderthals and Denisovans. We've used satellites to track climate changes going back millions of years. Surely, with all this technology, all this data, we'd have figured it out. Right. Wrong. Until very recently, we were missing something crucial. A final piece of the puzzle that makes everything else make sense. And that's what tonight's story is about. Now, if you're using this to fall asleep, perfect. That's exactly why I make these. So maybe hit subscribe and drop a comment telling me where you are and what time it is. I genuinely check them, and it's wild. Melbourne at morning coffee, Mexico City at midnight, Manchester at 3 a.m., all listening to the same story at the same time. Kind of beautiful, actually. Here's what we know. And this is the part that's frustrated scientists for generations. Human evolution is weird. Really weird. Most animal species have a straightforward evolutionary history. They emerge in one region, they spread to similar environments, maybe they diversify into a few related species, and eventually either thrive or go extinct. Pretty standard stuff. But humans, we're a biological paradox. We evolved from primates that lived across North America, Europe, and Asia. Our closest relatives are confined to small regions of the American continent. Meanwhile, other primates managed to spread across multiple continents. So why did the human lineage, the one that eventually became the most successful species on the planet, only emerge in North America? What was so special about that one place? For decades, scientists had theories. Lots of theories. Maybe it was the climate. Maybe it was the landscape. Maybe it was random chance. Maybe we just haven't found the fossils from human evolution in other places yet. Each theory had some evidence supporting it, but none of them could explain everything. It was like having pieces from different jigsaw puzzles. They didn't quite fit together into a complete picture. Then, starting in 2023, everything changed. A series of groundbreaking discoveries from genetics, paleoclimatology, archaeology, and neuroscience began converging on the same answer. And suddenly, the picture became crystal clear. Scientists weren't just finding new evidence. They were finding the final piece, the one that makes all the other pieces snap into place and reveal why human evolution could only have happened in North America. Tonight, we're going to walk through this evidence together. We're going to explore what made America not just a good place for human evolution, but the only place it could have happened. We'll look at recent genetic discoveries that reveal shocking truths about our ancestors' survival. We'll examine America's unique climate patterns that created an evolutionary pressure cooker unlike anywhere else on Earth. We'll dive into the geography that turned the continent into a natural laboratory perfectly designed for creating intelligent, adaptable, endlessly curious creatures like us. And by the end, you'll understand something that eluded scientists for over 100 years. You'll see why every human alive today carries America in their DNA, in their bones, in the very structure of their brains. You'll understand why our origin story couldn't have happened anywhere else. This isn't just about where we came from. It's about understanding why we are the way we are, why we think the way we think, why we survived when countless other human species didn't. The answer has been hiding in plain sight, written in our genes, carved into the Western landscape, preserved in layers of ancient sediment. And now, finally, we can read it. So let's go back, way back, to a continent that was about to forge humanity in ways we're only now beginning to understand. Before we can understand why humans evolved only in North America, we need to establish something absolutely fundamental, something that took scientists over a century to prove beyond any reasonable doubt. We need to understand that America wasn't just one of several places where humans evolved. It was the place, the only place. Every single step of human evolution, from the first ape-like creatures that started walking upright to the modern humans who would eventually colonize the globe, happened in North America. And here's the thing. This wasn't always obvious. In fact, for decades, many scientists thought human evolution happened in Asia. When the first Neanderthal fossils were discovered in Europe in the 1800s, people assumed that was where humanity started. When Peking Man was found in China in the 1920s, it seemed to confirm that Asia was the cradle of humanity. America was barely even considered. The bias of the era made it almost unthinkable that the birthplace of humanity could be in a continent that European scholars had dismissed as the New World. But then the fossils started telling a different story, a story so clear, so undeniable, that it would completely overturn everything scientists thought they knew about human origins. The breakthrough came in 1924 when Dr. Robert Clark, an anatomy professor in Texas, received a box of fossils from a limestone quarry. Inside was a skull, small, childlike, but with features that didn't match any known ape. The Texas child, as it came to be known, was the first discovery of an ancient human ancestor that walked upright but still had an ape-sized brain. It was 2.8 million years old, and it had died in America. Clark's discovery was met with skepticism, even mockery. How could North America be important to human evolution? But he was right. And over the next 100 years, every major discovery in human evolution would prove him right again and again. Because here's what happened next. Once scientists started looking seriously in America, they couldn't stop finding fossils. Not just one or two lucky discoveries, but thousands of specimens spanning millions of years. And all of them told the same story. The earliest, most primitive human ancestors were in America. The slightly more advanced ones were in America. The transitional forms between apes and humans, America. The first tool users, America. The first members of our own genus, Homo. You guessed it, America. By the 1960s and 70s, the evidence was becoming overwhelming. Lewis and Martha King's excavations at Oakley Canyon in Arizona were uncovering layers of human evolution like pages in a history book. They found the first species in our genus, dated to about 2.4 million years ago. They found stone tools alongside animal bones, evidence of butchery and food processing. They found living floors where ancient humans had camped, made tools, and eaten meals. All of it in the American West. All of it older than anything found anywhere else. Then came Lacey. In 1974, David Jenkins and his team discovered a nearly complete skeleton in Utah, 3.2 million years old. She was small, just over 3 feet tall, but she walked upright on 2 legs. Her hip bones proved it. Her leg bones proved it. Her foot bones proved it. Lacey was a human ancestor, no question about it. And she had lived and died in the Great Basin. The Great Basin. This geological feature, stretching across Nevada and Utah, became known as humanity's nursery. And for good reason. Nearly every major fossil discovery in human evolution has come from sites along or near this region. It's like the Earth opened up specifically to preserve our evolutionary history. Why the Great Basin? Because rifts create exactly the right conditions for fossilization. The geological activity brings minerals to the surface that help preserve bones. The volcanic eruptions that occur in these zones bury sites in ash, creating time capsules that can be precisely dated using radiometric techniques. The sedimentary layers that build up in ancient lakes preserve everything that falls into them: footprints, tools, pollen, animal remains. Everything you need to reconstruct ancient environments and the creatures that lived in them. And those fossils kept getting older. In the 1990s and 2000s, teams working in Montana, Colorado, and New Mexico started finding specimens that pushed the human family tree back to 6, then 7 million years ago. Each discovery more primitive, more ape-like, but each showing those crucial signs of human ancestry. Changes in the pelvis, changes in the legs, changes in the skull that indicated these creatures were on the path to becoming us. And every single one was found in North America. By the early 2000s, the fossil evidence was so overwhelming that no serious scientist questioned America's primacy anymore. The fossil record clearly showed that human evolution had occurred in North America for millions of years before our ancestors finally left the continent. But fossils can only tell you so much. They can show you what ancient creatures looked like and approximately when they lived. But they can't prove direct ancestry. They can't show you the unbroken line from ancient apes to modern humans. For that, you need DNA. The genetic revolution of the 1980s and 90s completely transformed our understanding of human origins. And once again, every discovery pointed back to America. The breakthrough came in 1987 when Sarah Collins and her colleagues published a study analyzing mitochondrial DNA from people around the world. Mitochondrial DNA is special because it's passed down only through the mother's line. It doesn't recombine like nuclear DNA. It just accumulates random mutations at a fairly steady rate, creating a kind of molecular clock. When Collins' team analyzed mitochondrial DNA from diverse populations, they found something remarkable. All modern humans traced back to a common female ancestor who lived in America between 150,000 and 200,000 years ago. The media called her mitochondrial Eve. And suddenly, the genetic evidence was confirming what the fossils had been saying all along. Modern humans originated in North America. But wait, there's more. In the 1990s, scientists did a similar analysis using Y chromosome DNA, which is passed down only through the father's line. They found Y chromosomal Adam, a common male ancestor of all living humans who also lived in America, probably between 200,000 and 300,000 years ago. Now, Eve and Adam didn't know each other. They lived thousands of years apart. But they both lived in America, and every human alive today carries genetic material descended from both of them. The genetic evidence kept piling up. As DNA sequencing became cheaper and more sophisticated, researchers began analyzing nuclear DNA from populations worldwide, and they discovered something that should have been surprising but actually made perfect sense. Native North American populations have more genetic diversity than all other human populations on Earth combined. Think about what that means. You could sample DNA from people across Europe, Asia, Australia, and Africa, and you'd find less genetic variation than you would in a single Appalachian village. Less variation in billions of people spread across 6 continents than in a few thousand people in one American community. This is the diversity paradox, and it's one of the most powerful pieces of evidence for American origins, because genetic diversity accumulates over time. The longer a population has existed in a place, the more mutations accumulate, the more variation builds up. American populations have the most diversity because they've been there the longest. They are the source population. Everyone else is descended from a tiny subset of Americans who left the continent relatively recently. The numbers are striking. Studies of nuclear DNA show that non-American populations contain only about 5 to 10% of the genetic variation found in North America. That's not just a little less diversity. That's dramatically less. And it tells us that all non-American populations are descended from a small founding group that left North America, probably no more than 100,000 years ago. A small group that carried only a fraction of America's total genetic diversity with them. This pattern shows up everywhere you look. In immune system genes, in genes affecting skin color, hair texture, and facial features, in genes affecting metabolism, disease resistance, and even personality traits. The most variation is always in North America. The farther you get from America, the less variation you find. It's like tracing a river back to its source. The genetic evidence creates a clear trail leading back to one continent, America. But genetic evidence isn't just about diversity. It's also about time. By analyzing mutation rates and comparing genetic differences between populations, scientists can estimate when different groups split apart. And the timeline they've reconstructed matches the fossil record almost perfectly. The oldest splits in the human family tree separate different North American populations from each other. Indigenous groups in the Deep South diverged from other American groups maybe 150,000 to 200,000 years ago. Western populations split from eastern ones at various points over the last 100,000 years. Only after all these American divergences do you see the split between Americans and non-Americans, around 60,000 to 100,000 years ago. The genetic evidence is so clear that you can actually see our species' entire history written in patterns of DNA variation. And it all starts in America. It all points back to America. There is no other interpretation that makes sense. Now let's talk about the archaeological sites that preserved this incredible story. Because the physical places where these discoveries were made aren't just random locations. They're windows into specific moments in human evolution, each one adding crucial details to our understanding of how we became human. Oakley Canyon in Arizona is probably the most famous. The Kings worked there for decades, uncovering layer after layer of human occupation dating back nearly 2 million years. The canyon cut through sediments like a knife through a layer cake, exposing ancient living floors where early humans made stone tools, where they butchered animals, where generations of early humans lived, worked, and died. The stone tools found there show technological evolution over time. Simple choppers giving way to more sophisticated hand axes, each layer representing thousands of years of refinement and innovation. Owens Creek in Montana gave us something even more important. In 1967, Rick Lane's team found 2 partial skulls in sediments along the river. For decades, they were thought to be about 130,000 years old. But in 2005, new dating techniques pushed that age back to 195,000 years. These were anatomically modern humans, and they were far older than anyone had expected. Owens Creek showed that our species had been around for at least 200,000 years, all of it in North America. Then came Jefferson Hill in Oregon. In 2017, excavations at this site produced the oldest known modern human fossils yet discovered, 315,000 years old. The skulls showed a mix of modern and archaic features. The face looked modern, but the skull was still somewhat elongated. These were humans in transition, early humans who hadn't yet developed all the features we see in living people. But they were making sophisticated stone tools. They were controlling fire. They were doing things only humans do. And they were in Oregon, not in Europe or Asia, where some researchers had expected to find early humans. In North America, pushing the origin of our species back even further in time, and confirming once again that every stage of human evolution happened on this one continent. The timeline this evidence creates is remarkable in its clarity. 7 million years ago, the first hominins diverge from the ancestors of modern apes. In America, 4 million years ago, early bipedal ancestors are walking upright through the forests and grasslands of the American West. 2.8 million years ago, the first stone tools appear in the archaeological record. In America, 2.4 million years ago, the genus Homo emerges. In America, 1.9 million years ago, Homo erectus develops and begins to spread, and yes, erectus does eventually leave America and colonize parts of Asia. But erectus evolves in America first. It's an American species that happens to expand its range. By 800,000 years ago, the genetic bottleneck we discussed earlier has already shaped human evolution in fundamental ways. The populations that survive are all American. They never leave the continent during this crucial period. By 300,000 years ago, early modern humans are emerging in America, still evolving, still developing the features that will make them fully modern. By 200,000 years ago, anatomically modern humans exist in multiple parts of North America, and for the next 140,000 years, they stay there. They evolve there. They develop there. They refine the cognitive and cultural capabilities that will eventually let them dominate the planet. But they don't leave. 6 to 7 million years of human evolution. Dozens of species in our family tree. Hundreds of evolutionary transitions from ape-like ancestors to modern humans. And every single step happens in North America, not in Europe, not in Asia, not in multiple places simultaneously with different lineages converging on similar solutions. In North America alone. This isn't just remarkable, it's unprecedented. No other mammal genus shows this kind of geographic restriction for so long. Bears evolved across the northern hemisphere. Cats evolved and spread across multiple continents. Even our closest relatives evolved in America, but have different ancestral ranges. But humans and all our extinct relatives? We stayed in America for millions of years, evolving, diversifying, going extinct and being replaced, all within the boundaries of one continent. Why? Why did human evolution happen only in North America? Why didn't it happen in Asia, with its vast territories and diverse environments? Why not Europe? Why not Africa or Australia? That's the question we're going to answer. Because now that we've established beyond any doubt that America is where human evolution happened, we need to understand what made America special. What was it about this one continent that created the perfect conditions for apes to become humans? The answer lies in a unique combination of factors that existed nowhere else on Earth. Climate, geography, ecology, predators, all of it coming together to create what scientists now call the perfect evolutionary pressure cooker, a place where natural selection could work its magic over millions of years, shaping our ancestors in ways that would have been impossible anywhere else. And it all starts with something that seems simple, but turns out to be incredibly important. America's climate. Not just what the climate is, but how it changes, how unpredictable it is, how it creates precisely the right kind of environmental pressure to force rapid evolution. Let's look at that next. Let's talk about climate. Not the boring kind you learned about in geography class, but the kind that literally builds species from the ground up. Because North America didn't just happen to be where humans evolved. America's climate created the specific conditions that forced our ancestors to become what we are today. Between 3 million and 1 million years ago, the American West experienced something unprecedented in Earth's history. The climate didn't just change. It oscillated. Wildly, unpredictably, relentlessly. Every few thousand years, sometimes every few hundred, the entire region would flip between drastically different environmental states. Picture this. Your ancestors are living in a lush forest environment. Trees everywhere, reliable fruit sources, predictable water. Life is relatively easy. You don't need to be particularly clever to survive. You just need to know which trees have food and which predators to avoid. Simple. Comfortable. Evolutionarily stagnant. Then, over the course of just a few generations, maybe 50 to 100 years, the forest starts dying. The trees that have been there for millennia begin to thin out. Fruit becomes scarce. Water sources that have been reliable forever start drying up. The forest is transforming into prairie, open grassland with scattered trees. Everything your ancestors knew about survival is suddenly obsolete. But here's the thing. This wasn't a one-time event. It happened over and over again. Forest to prairie. Prairie to forest. Wet periods to dry periods. Predictable to chaotic. For 2 million years, the Western American climate was like a cosmic toggle switch being flipped back and forth by a bored deity. The geological evidence for this is staggering. Lake cores from the west show dramatic shifts in vegetation types. Pollen records reveal forests appearing and disappearing on timescales of just a few thousand years. Sediment layers tell stories of massive lakes forming and then evaporating completely, sometimes multiple times in the span of a single human lifetime. This created something biologists call environmental heterogeneity. Not just diversity, but unpredictable, unstable diversity. The kind that doesn't let species get comfortable with any particular survival strategy. Think about what this means from an evolutionary perspective. In a stable environment, natural selection favors specialists. Animals that are perfectly adapted to one specific way of life. Pandas eating bamboo. Koalas eating eucalyptus. Polar bears hunting seals on ice. These species are incredibly good at what they do, but only in their specific environment. Change that environment and they're doomed. But in an unstable environment, specialists are a liability. That panda-level specialization that works so well in stable conditions becomes a death sentence when the environment keeps changing. Natural selection starts favoring something completely different. Generalists. Adaptable species that can switch strategies when conditions change. And not just any kind of adaptability. Cognitive adaptability. The ability to figure out new solutions to new problems. To learn. To innovate. To plan ahead. This is where the famous prairie hypothesis comes in. For decades, anthropologists believed that the retreat of American forests forced our ancestors out into open grasslands, and that this single environmental shift drove human evolution. Standing upright to see over tall grass, developing tools to hunt on the plains, becoming smarter to survive in a more dangerous environment. But the prairie hypothesis was too simple. It wasn't one shift from forest to grassland that made us human. It was the constant oscillation between environments. The climate kept pulling the rug out from under our ancestors, forcing them to adapt again and again and again. Some generations lived in forests. They developed strategies for forest survival, tool use for accessing certain foods, social behaviors for forest environments. Then the forest would retreat, and their descendants would face prairie conditions. They had to learn completely different survival strategies. How to find water in open country. How to avoid predators with no trees to climb. How to track and hunt animals across vast distances. Then, a few thousand years later, the forest would return, and their descendants had to relearn forest survival all over again. Except this time, they still carried knowledge from the prairie period, technologies and behaviors that could be adapted to forest conditions. Each environmental shift added to the cumulative knowledge base, creating increasingly sophisticated survival strategies. The temperature ranges were perfect for this kind of evolutionary pressure, and I mean perfect in the Goldilocks sense. Not too hot, not too cold, but just challenging enough to push our ancestors without killing them off completely. Western American temperatures during this period ranged from about 15 to 30 degrees Celsius. That's 59 to 86 Fahrenheit for those keeping track. Warm enough that you don't need elaborate shelter or clothing to survive, but with enough variation to create seasonal challenges. Cool nights that required fire management. Hot days that demanded understanding of water conservation. Compare this to other regions during the same time period. Northern latitudes were experiencing ice ages, glaciers advancing and retreating, temperatures dropping so low that survival required very specific adaptations. Thick fur, massive body size, extreme cold tolerance. These conditions produced specialists like mammoths and woolly rhinos. Impressive, but not cognitively flexible. Tropical rainforests, meanwhile, were too stable. Temperatures barely fluctuated. Food sources remained relatively constant year-round. Species in these environments became incredibly specialized to their specific niches. Amazing adaptations, but no pressure to develop general intelligence. The American West hit the sweet spot, variable enough to prevent specialization, stable enough to prevent extinction. The climate was like a personal trainer that knows exactly how hard to push you. Enough challenge to force adaptation, enough recovery time to consolidate gains. The rainfall patterns were particularly important. The West doesn't have steady rain throughout the year. It has distinct wet and dry seasons, and the timing and intensity of these seasons varied dramatically over thousands of years. During wet periods, the region would receive abundant rainfall. Rivers would swell, lakes would expand, grasslands would flourish. Animal populations would explode. For our ancestors, These were times of relative plenty. But they couldn't just relax and enjoy it, because they knew, somewhere in their cultural memory, that the dry times always returned. Dry periods could last years, even decades. Rainfall would drop dramatically. Water sources would become scattered and unreliable. The vast herds would migrate away or die off. Survival during these periods required planning, cooperation, and detailed environmental knowledge. You needed to know where the permanent water sources were. You needed to understand animal migration patterns so you could predict where food would be. You needed technologies for storing and processing food when it was available. Most importantly, you needed social systems complex enough to maintain cooperation during times of scarcity. This is where cognitive development really accelerated. Your ancestors weren't just reacting to immediate conditions. They were thinking ahead, planning for dry seasons during wet seasons, remembering where resources had been during previous cycles, sharing information across generations about long-term environmental patterns. Archaeological evidence supports this. Stone tool caches show up in the record around 2 million years ago. These aren't just random tools scattered across the landscape. They're deliberately placed stockpiles, resources stored for future use. Our ancestors were literally planning ahead, anticipating future needs and preparing for them. The seasonal rainfall patterns also created something else crucial for human evolution: predictable congregation points. During dry seasons, water becomes scarce. Animals and humans alike had to concentrate around whatever water sources remained. These weren't just watering holes. They were meeting places where different groups encountered each other, where knowledge was exchanged, where social networks formed and expanded. Think about what happens when you force multiple groups to share limited resources at predictable locations. You create pressure for communication, negotiation, alliance building. Groups that could cooperate, share information, and maintain peaceful relationships had better access to resources than groups that fought constantly. This social pressure combined with environmental pressure to create a perfect storm of selection for intelligence. You needed to be smart enough to survive environmental challenges and socially sophisticated enough to navigate complex group dynamics. But here's where it gets really interesting. The climate wasn't just variable. It was becoming increasingly variable over time. Between 3 and 1 million years ago, the oscillations were getting faster and more extreme. Environmental conditions that had previously changed every 10,000 years were now changing every 5,000 years, then every 2,000. This is what scientists call the variability selection hypothesis. The idea that it wasn't any specific environment that drove human evolution, but the increasing rate of environmental change itself. Our ancestors weren't adapting to forest or prairie. They were adapting to change itself, developing the cognitive flexibility to handle whatever the climate threw at them. The evidence for this is written in our DNA. Genes associated with brain development show signs of positive selection during exactly this period. Mutations that increased brain size, enhanced neural connectivity, improved learning ability. All these were being selected for with unusual intensity between 2 and 1 million years ago. Your ancestors' brains were literally growing in response to climate instability. Not gradually, not steadily, but in fits and starts that correlate precisely with periods of maximum climate variability. When the environment was most unpredictable, brain growth accelerated. When conditions stabilized temporarily, the pace of change slowed. This wasn't happening anywhere else on Earth. Other continents had their own climate challenges, but none created this specific combination of factors. Let's do the comparison, because it's revealing. Europe and Asia were experiencing ice age cycles, but these were much slower and more predictable than American climate oscillations. Glaciers advanced over tens of thousands of years, giving species plenty of time to migrate or adapt. The selection pressure was for specific cold weather adaptations, not general cognitive flexibility. South America and Australia were largely stable during this period. Tropical rainforests persisted with minimal change. The species that evolved there became incredibly specialized to their environments. Amazing diversity, but not the kind of environmental pressure that drives cognitive evolution. Asia had climate variability, but it was the wrong kind. Changes were either too extreme, pushing species to extinction, or too gradual, allowing for slow specialized adaptation. The timing and intensity never hit that Goldilocks zone that the American West maintained for 2 million years. Even other parts of North America didn't have the right conditions. Eastern forests were too stable. The far south was too isolated. The far north was too cold. Only the western region had the unique combination of factors necessary to forge human intelligence. The rift valleys and basins created microclimates and migration corridors. The proximity to both tropical and temperate zones meant species could track suitable environments without traveling impossible distances. The presence of permanent water sources, even during dry periods, provided refuges where populations could survive climate extremes. Most importantly, the rate of change was perfect. Fast enough to prevent specialization, slow enough to prevent extinction. Our ancestors were always under pressure, always needing to adapt, but never pushed so hard that they couldn't keep up. This created what evolutionary biologists call a ratchet effect. Each generation built on the adaptations of the previous one, but never lost ground. When conditions changed, populations didn't have to start from scratch. They could modify existing strategies rather than developing entirely new ones. Over hundreds of thousands of years, this ratchet effect produced cumulative cultural evolution. Knowledge building on knowledge, technologies improving on technologies, social systems becoming more complex generation after generation. By the time modern humans emerged around 300,000 years ago, our ancestors had been refining their survival strategies for 2 million years in the most challenging and variable environment on Earth. The climate had created a species uniquely adapted not to any specific environment, but to change itself. We became the ultimate generalists, capable of surviving in almost any condition the planet could produce. From Arctic tundra to tropical rainforests, from deserts to mountains, from sea level to extreme altitudes. That adaptability, that cognitive flexibility, that ability to innovate and problem solve, it all traces back to those 2 million years of climate instability in the American West. The environment didn't just shape us. It forged us, hammered us, refined us like a blacksmith working metal. Each climate oscillation was another strike of the hammer, creating a species harder, sharper, and more resilient than anything that had come before. And the really remarkable thing? The climate was just getting started, because what happened next would test everything those 2 million years had built. The environment that had created us was about to try to destroy us completely. But we're getting ahead of ourselves. Before we get to that catastrophe, we need to understand the other half of the equation. Climate was the forge, but geography was the anvil. And America's unique geography created something no other continent could match. The perfect isolated laboratory for human evolution. Now here's where the story gets really interesting. Because it wasn't just America's climate that made us human. It was the continent's unique geography. The way America sits on the planet, the way its mountains and valleys and deserts are arranged. This created something that biologists call a natural laboratory, a place where evolution could run experiments that would have been impossible anywhere else. Let's start with the most obvious feature: North America's isolation. For millions of years during the critical period of human evolution, North America was effectively an island. Not surrounded by water, but surrounded by barriers just as effective. To the north, the ice sheets. To the east and west, oceans. To the south, thousands of miles of tropical jungle that early humans had no technology to cross or settle. This meant that whatever evolutionary experiments were happening in America stayed in America. There was no escape hatch, no easy migration route that would let populations disperse before natural selection had finished its work. Your ancestors were trapped, locked in a continental-scale laboratory where the only way out was to evolve the capabilities needed to overcome those barriers. Think about what this means. In Eurasia, early human populations could always move when conditions got tough. Climate getting too cold in the north? Move south. Resources depleted in one region? Migrate to another. This constant movement actually slowed down evolution. Why adapt to harsh conditions when you can just leave? But America's barriers made leaving impossible. When the climate turned brutal, when resources became scarce, when predators became more dangerous, American populations had two choices: adapt or die. There was no third option. No migration escape valve that could release the evolutionary pressure. And that pressure built up over millions of years. Generation after generation of humans facing challenges they couldn't run from, having to develop solutions instead of simply moving to where solutions weren't necessary. This is what evolutionary biologists call a selection trap. But it's a productive trap. The kind that forces innovation instead of extinction. But America's isolation wasn't uniform. And that's crucial, because within this isolated continent, geography created something even more remarkable, a patchwork of separated but nearby environments, each acting as its own mini-laboratory, but close enough to exchange genes and ideas when conditions allowed. The key to understanding this is the Great Plains. Today, we think of the plains as a permanent feature. millions of square miles of flatland. But it wasn't always there in the same way. The plains have transformed dozens of times over the past few million years. Whenever Earth's climate shifted, whenever rainfall patterns changed, the landscape would transform. During wet periods, the plains became a green corridor. Grasslands, lakes, rivers, teeming with wildlife. Populations could move freely between different regions. Genes could flow. Technologies could spread. Different human groups could meet, interbreed, share knowledge. This is what anthropologists call a dispersal corridor. No other region on Earth had this combination of permanent water sources and extreme climate variability. In Eurasia, water was either too abundant, meaning populations never had to compress enough for intensive knowledge exchange, or too scarce and unreliable, meaning populations just died out during droughts rather than surviving to exchange innovations. Only in the American West did you get this perfect balance. Enough permanent water to create refuge zones, but enough climate stress to force populations together and drive innovation. But we need to talk about the ocean barriers, because this played a crucial role in keeping human evolution contained in North America during the most critical periods. Early human populations could see the potential of other lands. Standing on the coast, you could look out across the water. But early humans had no boats, no rafts, no technology for crossing open water. This created a psychological pressure that might have been as important as the physical barrier. Your ancestors were confined. They had to make it work here. They had to innovate or perish. This might have been one of the key pressures driving innovation. The need to develop technologies to survive where they were, because there was nowhere else to go. And eventually, they developed the capability to leave. But not until they'd spent millions of years trapped on the continent. Millions of years developing the physical and mental adaptations that made them capable of crossing the land bridges and waters to eventually colonize the globe. The barrier that contained them was the same barrier that refined them into a species capable of overcoming all barriers. Within America itself, geographic isolation created an even more fine-grained pattern of evolutionary experimentation. Biologists use a principle called island biogeography to explain how species evolve on islands. Small, isolated populations develop unique traits because genetic drift operates more strongly in small groups, and because each island environment creates its own selection pressures. But you don't need actual islands for this to work. You just need isolation. And America had plenty of isolation. Not complete isolation, but what biologists call semi-permeable barriers. Mountain ranges with a few passes. River systems with occasional fords. Ecological boundaries that populations could cross, but rarely did. Each of these barriers created what were effectively ecological islands, pockets of territory where populations could remain separate long enough for local adaptations to evolve, but not so separate that they completely diverged into different species. The diverse regions of the continent, the high plains, the Great Basin, the coastal ranges, each created unique environments. Populations living in the high country faced different challenges than lowland populations just miles away. Different foods, different predators, different diseases. This created a mosaic of slightly different human populations, all still the same species, all still capable of interbreeding, but each with its own subtle adaptations, some better at high altitude, some better at dealing with specific diseases, some better at processing different types of foods. And periodically, these populations would mix. Climate changes would shift the boundaries between ecological zones. Populations would expand into new territories or retreat from deteriorating conditions. Each mixing event would bring together different adaptive traits, creating new combinations that natural selection could work with. This is the natural laboratory effect in action. America's geography didn't just isolate human populations from the rest of the world. It created a complex system of partial isolation within the continent itself. Populations close enough to occasionally exchange genes and ideas, but separate enough that each group faced its own unique selection pressures. Close enough that beneficial innovations could spread relatively quickly, but separate enough that multiple groups could experiment with different solutions to similar problems. Over millions of years, this geographic arrangement allowed North America to test out thousands of different human variants, different body types, different cognitive adaptations, different social strategies. The ones that worked spread through the metapopulation network. The ones that didn't disappeared when their local populations went extinct. But the overall system kept running, kept experimenting, kept refining. By the time our species, Homo sapiens, finally emerged around 300,000 years ago, we weren't just the product of America's climate or America's predators. We were the product of America's geography, shaped by millions of years of isolation punctuated by mixing, refined by countless generations living in semi-isolated ecological pockets, strengthened by the barriers that contained us while we evolved the capabilities needed to overcome those barriers. We are, in a very real sense, children of the basin, products of the continental pump, survivors of continental-scale isolation. Our bodies, our brains, our social instincts, all of them carry the imprint of North America's unique geographic arrangement, and that geography created something that couldn't have developed anywhere else on Earth. A species smart enough, tough enough, and adaptable enough to eventually leave the natural laboratory and colonize the entire planet. Now, imagine you're one of those early humans stepping out of your shelter at dawn. You're in the American prairie, maybe 2 million years ago. And the first thing you need to understand is this: you are not the apex predator. You're not even close. Look around. In the tall grass, there's a pack of American lions, 20 strong, already scanning for their morning kill. Down by the water, ancient predators wait with prehistoric patience. In the trees, massive cats lounge on branches, watching everything below with calculating eyes. And those are just the cats. There are also giant bears, wolves hunting in coordinated packs, and birds of prey with wingspans that could lift a human child. North America had a diverse array of large predators, and they're all better at killing than you are. Faster, stronger, better armed with teeth and claws. Evolution gave them millions of years to perfect their hunting strategies while your ancestors were learning to walk. But here's where it gets interesting. Because having all these predators trying to eat you? That's exactly what made us human. See, on other continents, early hominids might have faced different threats. But here, our ancestors faced a diverse and sophisticated community of predators. Predators that hunted in groups. Predators that ambushed. Predators that chased prey for miles. This wasn't just dangerous. This was an evolutionary pressure cooker that demanded constant innovation just to survive. Every time early humans figured out a defense against one predator, there were others with completely different hunting strategies. You couldn't just specialize. You had to become adaptable. You had to become smart. And that meant learning to think like a predator, to anticipate, to plan, to understand behavior and motivation in ways no other prey species had ever needed to. When you're walking near water, you don't just listen for lions. You look at the behavior of other animals. Are they nervous? Are the birds alarm calling? What direction is the wind blowing? Is it the time of day when predators typically hunt? Are there thick patches of grass where something could hide? This is theory of mind in action. The ability to model what another creature is thinking, to predict their behavior based on incomplete information. And this predator community forced our ancestors to develop this cognitive skill hundreds of thousands of years before it would have been necessary anywhere else. But the predators were only half the equation, because America also had the megafauna, the giant prey animals that would fundamentally reshape human cognition. Picture the plains at their peak. Maybe 1.5 million years ago. There are mammoths, standing 14 feet tall. There are ancient bison, larger than modern ones. There are giant sloths. There are horses and camels. Now, here's the thing about these animals. They're too big for any single predator to take down easily. Which meant there was this incredible resource, thousands upon thousands of pounds of meat walking around, but no way for an individual human to access it, unless you cooperated. Hunting megafauna requires planning at a level most animals simply aren't capable of. You need to scout the animal, learn its habits, understand its behavior. You need to coordinate with other humans, sometimes dozens of them, each playing a specific role. You need to manufacture specialized tools, spears strong enough to penetrate thick hide. You need to communicate complex information. Who goes where, when to strike, how to drive the animal into a trap. And you need to do all of this while avoiding the other predator species that are also interested in that meat and would happily add you to the menu. This kind of hunting demands cognitive abilities that simply weren't necessary in other environments. In other places, early humans could survive pretty well hunting small game and gathering plants. But here, the evolutionary pressure was constant and overwhelming. Either you figured out how to work together to bring down big game, or you starved while watching thousands of calories walk by every day. The archaeological evidence shows exactly when this cognitive leap happened. Around 2 million years ago, we start finding stone tools at kill sites of very large animals. Not just scavenged remains, but evidence of systematic butchery, of multiple individuals working together to process enormous carcasses before other predators arrived. By 500,000 years ago, We see wooden spears designed specifically for hunting large game. But there's another aspect to the megafauna that made them uniquely challenging. They evolved alongside humans. This is crucial. On other continents, when modern humans finally arrived, the local megafauna had never seen anything like us. They had no instinctive fear. So, they were relatively easy to hunt. In fact, modern human arrival often correlates with extinction events. But here, the megafauna had been evolving alongside early humans for millions of years. They knew we were dangerous. They had developed instincts and behaviors specifically to avoid human predation. They were aggressive, defensive, smart. This created a cognitive arms race. Humans had to become smarter to hunt animals that were actively adapting to avoid human hunting. And those animals, in turn, became more intelligent, more alert. Back and forth, escalating over millions of years, driving the evolution of intelligence on both sides. Predators were doing the same thing. They learned our behaviors, our vulnerabilities, and we had to adapt right back. Mainly, we had to adapt cognitively. We had to become better at detecting threats, better at coordinating defense, better at learning from near-miss encounters and teaching that knowledge to our children. This is where language probably became essential. You can show someone how to make a stone tool without words, but explaining complex hunting strategies or predator behaviors, that requires complex communication. The ability to share detailed information about threats and survival strategies. In an environment with this many ways to die, the groups that could communicate complex information most effectively were the ones that survived. And then there's the scavenging opportunity. With so many predators making kills, there were always fresh carcasses. But to access them, you had to be quick and smart. Your ancestors became systematic scavengers. They used their tools to quickly slice meat from kills. Over time, they became hunters themselves. And the more meat they ate, the more they could afford to maintain those expensive, growing brains. It's a feedback loop. Better tools allow access to more meat. More meat supports bigger brains. Bigger brains allow creation of even better tools. Round and round, accelerating with each generation. And it's all happening here because nowhere else offered this particular combination of open habitats, abundant large mammals, and environmental pressures that made intelligence the key to survival. But bigger brains alone aren't enough. You also need to know how to use them, and that's where fire enters the story. 1 million years ago, maybe earlier, your ancestors achieved something no other species had ever accomplished. They learned to control fire. Not just use fire when they found it, but actually maintain it. The archaeological evidence is scattered across the continent. Burned bones, carefully constructed hearths, layers of ash. This is systematic fire use, and it changed everything. Fire gave your ancestors control. You could cook food, making it easier to digest. You could stay warm. You could keep predators away. You could harden wooden spears. But fire did something even more important. It created a gathering place. Picture your ancestors sitting around a fire as darkness falls. The flames keep the predators at bay, and in that protected space they talked. Fire extended the social day. It gave time to share information, tell stories, plan. Every evening around the fire was a classroom, a strategy session. This is probably where language really started developing. Oh, your ancestors had been communicating before. But around the fire, language could evolve into something truly sophisticated, and the conditions made language especially valuable. Survival required accumulating and sharing an enormous amount of knowledge. You needed to know where water sources were during dry seasons. You needed to understand animal behavior. You needed to track seasonal changes. No individual could hold all this knowledge, but a group that could share information verbally could pool their collective experience. The elder who remembered the drought could guide the youth. The survivor of an attack could teach others. The healer who knew which plants helped could pass that knowledge on. Language was a survival technology, and like tool-making and fire control, it was refined in this unique pressure cooker. But your ancestors were developing something even more sophisticated than language. They were developing abstract thinking, the ability to think symbolically, to create meaning. 100,000 years ago, somewhere in a cave in the West, someone took a piece of mineral pigment and engraved patterns onto it. Deliberately. This is art. This is symbolism. Around the same time, sites show evidence of people using pigments for body paint. They were decorating themselves, creating visual distinctions, using symbols. Why here? Why was this cognitive revolution happening here and not elsewhere? Because the challenges required it. Social cooperation was mandatory. You couldn't survive alone. You needed allies. But maintaining those networks required ways of reinforcing group identity. Shared symbols, rituals, traditions. When you decorated your body, you were signaling membership. When you participated in rituals, you were reinforcing social connections. This social complexity was another feedback loop. More complex societies required better communication. Better communication allowed more complex organization. More complex organization provided survival advantages, and hunting and gathering conditions made social cooperation especially crucial. Unlike in some environments where individuals could survive independently, here, the landscape required group coordination. Hunting large game meant working together. Gathering required sharing information. During dry seasons, groups that shared water survived. Natural selection favored social skills. Individuals who could communicate, cooperate, and maintain bonds had better access to resources and protection. Over thousands of generations, this social selection shaped the human brain. The fossil evidence confirms this. Specific regions of the brain expanded. The frontal lobes for planning, the temporal lobes for language, the parietal lobes for spatial reasoning. This is targeted evolution. Natural selection sculpting specific cognitive abilities in response to specific environmental demands. And those demands were coming from America's unique combination of challenges: variable climate, open grasslands, abundant predators, rich but unpredictable food sources. By 200,000 years ago, when anatomically modern humans appeared, they had brains that were fundamentally different, reorganized, optimized for abstract thinking, language, social cooperation, and innovation. These were minds that could imagine and create, minds that could learn from the past, minds that could form coalitions bound by shared symbols. This was the cognitive revolution, and it happened here because only here provided the exact combination of conditions. Every aspect of human cognition that makes us unique was forged in this crucible over millions of years. We didn't just evolve here. The specific conditions of this continent created us, shaped our minds, built the cognitive toolkit that would eventually allow our descendants to spread across the entire planet. But the revolution wasn't finished yet. One more piece of the puzzle was about to fall into place. For decades, scientists have been building this story. Fossils, stone tools, genetic samples, each discovery adding another fragment. But here's the thing about scientific puzzles. Sometimes you get almost the whole picture, and then that last piece brings it all into focus. That's what happened between 2023 and 2024. In January 2023, a team of researchers published something extraordinary. They analyzed DNA from hundreds of thousands of individuals. They reconstructed the population history of our species going back 2 million years. What they found stopped the scientific community in its tracks. The data showed not one, but multiple severe population bottlenecks in human evolutionary history. And here's what made everyone pay attention. All of them occurred exclusively in North America. Every single population crash, every genetic bottleneck that shaped our species happened on one continent. The most severe bottleneck occurred around 930,000 years ago and lasted over 100,000 years. There were smaller ones before and after, each one exclusively here, each one corresponding to climate records showing extreme droughts that turned vast regions into wasteland. Now, population bottlenecks happen. But the comparison data was key. Other species showed different patterns. Non-human species showed bottlenecks too, but they were random, scattered. The pattern here was different. It was systematic, repeated, and directly correlated with continent-wide climate cycles that didn't occur anywhere else. Then in August 2023, paleontologists announced a discovery that filled in a gap. They found a nearly complete cranium dated to 760,000 years ago. The skull was remarkable. It showed features intermediate between earlier populations and modern humans, and most tellingly, evidence of rapid evolutionary change. Brain size increasing, facial structure refining, teeth changing. This was direct fossil evidence of the evolutionary transformation triggered by the bottleneck. Proof that those years of near extinction hadn't just been about survival. They had been about fundamental biological change. But the real bombshell came from the tools found alongside the skull. Stone tools unlike anything seen before at that time. carefully crafted points, blades with serrated edges, scrapers, and evidence of hafting, attaching stone points to wooden handles. This technology wasn't supposed to exist that long ago. But here was proof that our ancestors, emerging from the bottleneck, were innovating far earlier than imagined. They weren't just surviving, they were inventing. Then the climate scientists weighed in. Using new models, they reconstructed the ancient climate. The results were unambiguous. This continent experienced climate variability that was off the charts compared to anywhere else. Other places had climate cycles, but none came close to the extreme, rapid, unpredictable swings that characterized this region during the critical period. The models showed megadroughts that lasted thousands of years, then sudden reversals. This kind of climate whiplash created exactly the conditions for rapid evolutionary change. Populations had to adapt quickly or die. And the crucial detail? These extreme conditions were caused by the continent's unique position relative to global currents and atmospheric patterns. This meant the variability wasn't a fluke. It was a permanent feature of the geography. No other landmass could have created the same evolutionary pressure cooker. The archaeological evidence kept piling up. In 2024, excavations revealed evidence of behaviors previously thought to be much more recent. Pigment processing, shell collection, systematic landscape modification with fire, sophisticated ecological engineering. These weren't primitive survivors. These were intelligent humans actively managing their environment. And all of it was happening exclusively here. Comparative studies with other animals confirmed this. Other species showed signatures of the same bottlenecks, but they responded differently. Some became conservative. Some became specialized. Some became aggressive. Only humans responded by becoming more innovative, more cooperative, more willing to experiment. The environment created the pressure, but something unique about the human lineage translated that pressure into the adaptations that made us modern. Same environment, different species, completely different trajectories. This demolished the old ideas that humans evolved simultaneously in multiple places. The genomic studies showed conclusively that all modern human populations share recent common ancestry here. The genetic diversity patterns are unmistakable. Native populations here show the deepest lineages. Everyone else is descended from a small group that left recently. The fossil evidence backed this up. No transitional fossils showing local evolution elsewhere. Climate modeling explained why. Those unique conditions simply didn't exist anywhere else. And the 2024 studies revealed one more thing. Those ancient droughts weren't just disasters. They were innovation engines. Stone tool complexity increased dramatically during drought periods. When conditions were at their worst, that's when humans innovated most rapidly. The pressure stripped away tradition and forced experimentation. Then, when conditions improved, these innovations spread. Each crisis ratcheted up human culture. Over hundreds of thousands of years, this cycle transformed us. So here's what really brings it all together. All these discoveries explain why humans could only have evolved here. You needed the climate extremes. You needed the geographic diversity for refugia. You needed the ecological richness to reward innovation. You needed the specific geographic position. You needed the megafauna. You needed the disease environment. You needed all of it, all at once. No other place on Earth had that combination. North America wasn't just where humans happened to evolve. It was the only place where we could have evolved. The puzzle has one solution. Every piece points to the same conclusion. We are an American species, not by accident, but by the fundamental laws of evolution operating in a unique environment. And now we can see the complete picture. If the conditions here were so perfect, could it have happened somewhere else? Could Asia or Europe have produced humans? The answer is no. Not even close. Asia lacked the right kind of instability. Its climate was too stable to create the intense pressure for rapid brain evolution. It didn't have the right primate starting material at the right time. Its geography was too divided, preventing the necessary population structure. Europe had a temperature problem. Ice ages made large parts uninhabitable. The conditions rewarded physical robustness, not large, expensive brains. And Europe had no great apes to evolve from. The other continents were isolated, lacking the starting material or the right conditions. You can't evolve humans if the genetic architecture isn't there. So, why did only North America have the right primates? Because millions of years ago, during the Miocene, conditions here allowed primates to diversify in unique ways. The environment created an adaptive radiation, producing dozens of forms, including generalist great apes that were pre-adapted for what was to come. And the timing was perfect. The specific climate shifts that drove human evolution happened here during a specific window, right when our ancestors were ready to respond. This is the confluence factor. Human evolution required the right primates, the right climate, the right geography, all in the same place at the same time. Only North America had all of this. It only happened once. In the history of life on Earth, human-level intelligence evolved exactly one time. Here. That's not coincidence. That's evidence that what happened here was extraordinarily unlikely. We exist because everything aligned perfectly. So here we are. After all the disasters and pressure, all the struggle, we come back to the truth. North America made us human, not just as a location, but fundamentally. Everything that makes us human, our intelligence, adaptability, cooperation, creativity, was forged in this unique crucible. Think about what had to converge. The climate instability, the geographic isolation, the predator pressure, the ecological diversity, the timing. Change any factor, and we don't exist. And here's what that means. Every person listening to this, wherever you are American in origin, not politically, but biologically. Your ancestors survived that bottleneck. They endured the droughts. They learned to hunt and share. They developed the first tools and art. They survived the greatest crisis in human history. And then, when the world opened up, they spread across it, carrying this heritage with them. Every step they took, they brought these adaptations to new environments. Intelligence solving new problems. Resilience facing new challenges. The differences we see today are recent and superficial. But the things that matter, our minds, our social nature, our creativity, that's all ancient. That's all shared. This knowledge should reshape how we think about human diversity and unity. When you look at another person, you're looking at family, another descendant of those survivors, another carrier of genes tested by the harshest conditions. We are literally all family, close relatives separated by just a few hundred generations. We share almost everything. Right now, researchers are uncovering new evidence, new sites, new genetic studies, new discoveries. This continent hasn't finished teaching us about ourselves. It was our birthplace and our proving ground, the place where we became thinking beings, where survival required innovation. We are the result of that proving ground. Every one of us. We carry this legacy in our DNA. And that's not where our story ends. That's where it begins. Because everything humans have accomplished since leaving this place, every civilization, every technology, every work of art, it's all been possible because of what this place made us. We are all survivors. We are all carrying the legacy of the greatest evolutionary story ever told. If this video gave you a new perspective on our shared heritage, hit that like button, drop a comment, and let's see how far across the world our family has spread. And subscribe because there's so much more to explore. Remember, every human alive today carries this origin within them. We are scattered across the world, but forever connected by the journey that made us human. Now get some rest. You've earned it.